Right, we're going to look at angles in the same segment of a circle. This is what we had finished on in the last video. Let me just erase the board, at least part of the board, because we're going to use some of the information here. Now we're going to look at angles in the same segment, right? Well, remember, last time we looked at angles, what we looked at was the fact that the angle at the center is twice the angle at the circumference of the circle. When you have the angles at the center formed by two radii, and the angle at the circumference is formed by two chords that lie on the same main chord. Now, if this here, let me draw a line. If this is a chord, another way to put it is that when you have angles that lie on a chord, remember this is my chord. If the two angles lie on the same chord, then the one at the center is twice the one at the circumference, right? So if the one at the circumference, that was accidental, let me erase that. If the angle at the circumference is x, then the angle at the center is 2x. Both of them are lying on this chord because the 2x is lying down on the chord here, and then the x is lying on the chord here, right? So both the 2x and the x are lying on this chord. When the two angles lie on the same chord, the angle subtended at the center is twice the angle subtended at the circumference. So right here is on the circumference, this area is where the angle x touches the circumference. And of course, this is the center, right? All right. Now, let's look at angles in the same segment. Let me just make some adjustment here. Let me delete this, accidentally deleted my circle. I want my circle. Let me delete this radius and delete this chord. Delete this point and this point as well. Now, suppose we have a chord from here to here, right? This is the chord. We have another chord that forms an angle at the circumference, and two other chords, I should say, that form an angle at the circumference, like this. Good. Then we have two more chords that form another angle at the circumference, like this. What we want to do is compare this angle and this angle. Now, angles in the same segment is what we're dealing with. So therefore, what we're really looking at are the two segments. Let me shade this segment. You have this segment. Remember, this is a chord that separates the circle into two segments. So you have this segment up here, and then we have this segment under here, right? So you have all of this segment up here above the chord, and then this segment below here. So let me just erase what I have. So this is my chord with both angles lying on the chord. Up here you have one segment. Everything that is above it up here, one segment, and then below here you have another segment right in this area. That's what they're talking about. So this angle is lying within the top segment here, and this angle is also lying within that big top segment there. Now, angles in the same segment of a circle are equal. Alright? They are equal. You can make a note of that. Angles within the same segment of a circle are equal. So this angle here is equal to this angle here. And it doesn't matter where they are formed. The fact is, both angles are lying on this chord. One thing you can say is that when two angles lie on the same chord and they are in the same segment, they are always equal. So if I should move this here like that, and move this here like that, and then draw my angles on them, what I would have is this and this, right? So those two angles would be equal. If I move the joint here and move this joint up here, what you will find out is that this angle and this angle are equal. And if I move this joint where the two chords meet and put them here, the angle never changes and is always equal to that other angle over there. Look at this. You see, they match each other. They're always equal to each other, no matter where you put them. Alright? So, therefore, this angle here and this angle here are always equal. So therefore, when two angles are formed at the circumference in the same segment and they both lie on the same chord, then those two angles are always equal as long as they're in the same segment. Alright, we'll look at another property in a different video.